Hello, thank you for watching this video. So, on this video I'll be doing November 2020 question paper, Mathematics paper 1. And on this, the question that I'll be doing is question 5, which is the exponential function. So, I'll read the question and then answer the question that follow. The graph f of x is equal to 3 raised negative x is sketched below. A is the y-intercept of f. B is a point of intersection of f and the line y is equal to 9. I will try to read this again. The graph of f of x equal to 3 raised negative x is sketched below. A is the y-intercept of f. B is the point of intersection of f and the line y is equal to 9. So this statement is basically telling us what we can see here. So the graph f of x is sketched below. Here is f of x. F is sketched here, right? A is the y-intercept of A. Here is y, A, which is the y-intercept of f. B is the point of intersection of f and the line y is equal to 9. So this point B is the point of intersection between these two. So these two are intersecting there. So the statement is basically telling us what we can read on this. Okay. 5.1. Write down the coordinates of A. They are asking you what are the coordinates of A. So you have that your question 5. You know 5.1. Okay. You know that f of x is equal to 3 raised negative x, right? So you are told that A is the y-intercept. So at y-intercept, this is the same as the line x is equal to 0. This is the line y is equal to 0. So you know at this point, you know that your x is 0. Then the only thing that you need to find is the y value here. So which means if your x is 0 there, you have, okay, f at 0 is equal to 3 raised 0 and negative 0, which is equal to 1. So the coordinates of A is 0 and 1. So A is 0 and 1. These are the coordinates of A. 5.2. Determine the coordinates of B. At 5.2, they want you to find the coordinates of B. So you have two functions, f and y is equal to 9. So this is the line y is equal to 9. So at point B, they have the same y coordinate. So y is equal to 9, and the second y is equal to 3 raised x, because f is equal to 3 raised x. So if you want, you don't know the x value here. You don't know what the x value is there, right? So you can say, okay, b at that point is defined by this function. So the point b on this function on f is defined by this, right? So, and then what do? You say, okay, at the point of intersection, your functions are equal, which means your f of, so this is 5.2. Your f of x is equal to y, right? Because these are the two functions that you have. You have f here, you have y there. They meet at that point, which means their y values are equal. That's why we're equating the y values. So the y value of f is defined by that, and the y value of y is defined by 9. So what do? You say, okay, 3 raised negative x is equal to 9, right? So you say 3 raised, so we need a new marker. So you say, this one is even worse. This one is even permanent. Oh, I'm in trouble. Move. So 3 raised negative x is equal to 3 raised 2. So so 3, this is equal to 9, and this is equal to 9. So when the bases are the same, you just drop them and leave the exponents out. So you have negative x is equal to 2. Therefore, x is equal to minus 2. So you find that your x value here is minus 2, right? Then you have your y value is 9. So the coordinates for B is minus 2 and 9. So the coordinates for B is minus 2 and 9. So one might be wondering, so why did I drop my bases there? So if your bases are the same, the only way they will be equal when you raise them by some exponents is if your exponents are the same. So let's proceed. Let's do 5.3. 5.3 read as follows. Write down the domain of f inverse. So write down the domain of the inverse of f. So what they want you to do is find the domain of this, right? They want you to find the domain of this inverse. Let me just write it down like this. Of f inverse. That's what they want you to do. They want you to write down the domain of that. So, what is actually the first question that we must ask? What is the domain in the first place? So, actually, what is the inverse? So, the inverse is a reflection of f, right, by the line y is equal to x. So, that's what your inverse is. So, you reflect this function f by this line y is equal to x. So what happens is your x and y become y and x. So you just swap this thing around, swap your things, your function around. That's what you do. So the reflection, the inverse, it is a reflection of this line, a reflection of this function f about the line y is equal to x, right? And this is basically what you do. Just flip the x and y coordinates around. So to do this, I would say it is important for you to know the domain and range of this function, right? Because if you know the domain of f, it will become the range of f, of f inverse. If you know the domain, if you know the domain, if you know the range of f, it will become a domain of f inverse. Because like I said, you swap this thing around by reflecting it by that line. So outside the important things, you must know the domain of f and the range of f. Then you know that the domain of f will become the range of f. The domain of f will become the range of f inverse. And the range of inverse will become the domain of f inverse. That's one way of approaching this. So let's find the domain and ranges of f. So we need the domain of the inverse. There's no need for us to find the domain of f because it will not be helpful in this question. But for educational purposes and because you're doing this, you are watching this video, I'll do the domain and the range so that maybe you can know how to do them. What is the domain? A domain, it is the set of values over which your function or on which your function is defined. So in this case of f, f is equal to minus x. F is equal to minus x is defined on the real line, right? So on this real line, f is defined everywhere. There's no point where on this real line, there's no value that you can pick such that when you plug it here or substitute on f, on this equation f of x equal to 3 raised to the minus x, the function will be undefined, right? So this function is defined everywhere on the real line. That's how you find your domain. You're asking yourself, where is this function defined on the real line? Which is in the real line in this case, because your function is defined on the real line. Where is your function defined on the real line? So, as we say, this function is defined everywhere here, right? So what does that tell you? This tells you that for your domain, you say, okay, the domain of f, right? Say your x is an element of real numbers, which means x is a real number, which means x is defined everywhere. X is inside the real number because it's defined everywhere along this line. That's your domain, because the function is defined everywhere, because there's no point where this function is undefined, or where there's an asymptote, or there's an empty or discontinuity. So, or you can write it and say, same thing, x is an element negative infinity to positive infinity. So that is exactly the same thing, right? And then you go to your range of f. So what is the range? So the range, it is all the values, it is the collection of all the y values that you get by substituting the x values, which means it is a set of all values to which your function is mapped to, right? So it's all these y values that correspond, it's all these y values that are used by this function of ours. So this function of ours uses all the y values that are above 0, because for any y value that is above 0, you can always find a corresponding x value. That's how you define a range. So these ones that are below here, we can't use them because our function does not use, it is not defined. If you can take -1, there's no way this function can get to -1, right? So what you do, you say, okay, my domain is a set of all y values that have a corresponding x value which means for every y value you can find a corresponding x value, or the set of all y values that are used by a function, which are all go to infinity all the way to above 0. So your range, you say, okay, y is greater than 0, or similar thing, x is an element of 0 to infinity. This is your range for f. So like I said, because f is defined by reflecting, because the inverse of f is defined by reflecting f by this line, things flip around. Your domain of f becomes the range of f inverse. Your range of f becomes the domain of f inverse. So now, they ask you to determine what the domain of the inverse is, which means now it will be similar to the range of f, but the only difference is, what you should keep in mind is that it is defined along the x-axis. So your range was defined on the y-axis. So if you're saying this range becomes the domain, which means now you must keep the same structure but only keep in mind that it's defined on the x-axis. So your domain of f inverse is x is greater than 0. Oh, sorry, this should be y here. Or what else? Or you can write it this way. Say x is an element 0 to infinity. So that's how you do question 5.3. Then you proceed to question 5.4. So 5.4, describe the translation from f to h of s. Okay, so we do question 5.4 now. Okay. (5.4) describe the translation from f to h of s. So they want you to describe this translation from f of x, which is equal to 3 raised minus x, to get to h of x is equal to 27 over 3 raised x. So they want you to tell them, how did you move here to get that? Right? So let's look at this part. So if you look at h of x, you can say, okay, it is equal to 3 raised 3 over 3 raised x, right? Which you can take this up here, write this as 3 times 3 raised x times 3 raised minus x, right? Which you can further say is 3 raised negative x plus 3, which is equal to 3 raised negative x minus 3. Because this is how this originally looked like. So this you can say this function is this one, except that it's moved 3 units to the right. So this function is exactly the same as this one, except that now this looks like x minus 3, which is, this has been translated 3 units to the right. So the translation is 3 units to the right, straight down. Go to 5.5. Determine for which values of x. This is it. Straightforward. So they ask how did you get from this to that. So you just simplify this. So you can see that this looks like this, except looks like we have shifted it 3 units to the right. I don't know how to explain it further. It is this. So 5.5, determine for which values of x is h of x less than 1. So we do 5.5. 5.5 reads as follows. Determine values of x for which h of x is less than 1. So they want us to determine the values of x for which 5.5 values of x for which h of x is less than 1. This is basically question 1, except that you have to plug your equation yourself or substitute your h of x there. So you're told that your h of x is equal to 27 over 3 raised x, right? So they say determine the values of x for which h of x is less than 1. So you know your h of x is equal to 27. So substitute your h of x there. 27 over 3 raised x is less than 1. Solve like normal. Cross multiply. 27 is less than 3 raised x. 3 is less than 3 raised x. So you drop the bases. So your x your 3 should be less than x, or your x should be greater than 3. So this is how you do this one. So what this tells you is that for all x greater than 3, this will be less than 1, which is true because this is 3 raised 3, right? So if x is equal to 3, then you have 1 this side. 1 is not less than 1, right? They're equal. So, but if your x is greater than 3, then this part with the numerator will always, the denominator will always be bigger than your numerator. As a result, this will always be less than 1 because the denominator will always be big. So if your denominator is big, your what is this? If your denominator is bigger than the numerator, your fraction will always be less than 1 because it will be 0 point something. This is how you do this question. And you're done with question 5.